Find the number of zeros at the end of 1132 factorial and 1144 factorial times 348 factorial times 17 factorial. So one thing I would quickly like to tell you is that whatever number of zeros are in this factorial, let's say that it has 2 zeros, for example, at the end of it, and say this number here, whatever the product is, this number has one single zero, and let's say this number has 3 zeros. I'm just putting some random numbers. So at the end, when we'll together take the product, the total number of zeros will be sum of all the zeros that we obtain individually. That is 3 plus 1 plus 2, that is 6 zeros. 6 zeros. So having said that, now let us calculate how can we find the number of zeros at the end of the factorial. So now let's start with the first one. In the first one, I'll just start dividing 1132 with 5. 1132 divided by 5 will give me 5 2s are 10. When I'll subtract them, I'll get 1 here, 3 comes down, 5 2s are 10. Again I'll subtract them, I'll get a 3 and a 2, and 5 6 are 30 with a remainder of 2. So I got 226 as a remainder. So this 226 represents that I'll have 226 fives, at least 226 fives in 1132. I'll have 226 such numbers which are exactly divisible by 5. Now let us count the number of 25s. How many extra fives do we have? So for that, what I'll do, I'll just divide this 226 that I obtained here again with a 5 so that I can get extra number of fives. So 5 4s are 20. When I'll subtract them, I'll get a 6 here and 2 here. 26. 5 5s are 25, and I'll have 1 as a remainder. So I'll add this quotient that I obtain here, 45, into it. So this 45s are extra 5s that I'll get because 25 will be a multiple of them. For example, numbers like 25, 50, they will give me an extra 5 apart from 5, because 25 is what? 5 times 5. So this one 5 I included as a multiple of 5. This other 5 I am including as a multiple of 25. Now let us move to 625. So 45, I'll again divide this quotient with a 5. So 5 9s are 45 and no remainder left behind. So I got 9 here. So I'll add 9 to this. So this 9 will represent those extra 5s which I will get as a multiple of 625, as a multiple of 125. That is numbers like, say, I'll take number 125 or numbers like 250. So 125 is basically 5 times 5 times 5. So this first 5 was included as a multiple of 5. This second 5 was included as a multiple of 25. This third 5 will be included as a multiple of 125. Now I cannot go beyond this, or maybe I can. Why not? I can surely go beyond this. So this 9 I have here. So I'll again divide this 9 with a 5. I'll again divide this 9 with a 5. So 5 1s are 5 and I got 4 as a remainder. Now I cannot move forward because whenever I'll divide 1 with 5, I'll get 0 as a quotient. So I'll end my process here after adding a 1 here, because this 1 represents an extra 5 which I will get as next 5 times 5 times 5 times 5, that is 625. Now since this 1132 is greater than 625, so obviously I can have a numbers which contain 4 5s as well, which are multiple of 625. So this one represents such numbers. So I'll add 1, and now I'll add all of them. So this will give me 226 plus 226 plus 45 plus 9 plus 110 is 55, which gives me 6 plus 5 is 11, 1 carry, 5 2 7 8 and 2 281. So this number here, this factorial here, will contain 281 zeros at the end of it. Now let us move on to the B part. So let me erase this so that I can have some space for writing here. Okay, so let us calculate the second one. We have here 1144 factorial times 348 factorial, and you can actually pause the video and try it on your own, because the basic idea behind this I already gave it to you in the starting of the video, that calculate the number of zeros at the end of this, at the end of this, and at the end of this, and just add them up, so you'll get the total number of zeros at the end of this whole factorial. So let us start with 1144. So I'll divide 1144 with 5. So 5 2s are 10, 1 4, again 5 2s are 10, 4 and 4, and then I have 8s are 40 with a 4 remainder. So 228. So I'll just write it here, 228 plus, I'll again divide this 228 with a 5. So 5 4s are 20, 2 8, and 5 5s are 25. So 3 as a remainder. So plus 45 plus, I'll again divide this 45 with a 5. So 5 9s are 45, and I have no remainder here. So I'll add this 9 as well. Plus, I'll again divide this 9 with a 5. So 5 1s are 5, remainder is 4. So I'll add this 1 as well. So this many numbers, this total here will represent the number of zeros at the end of 1144 factorial. Now let us move on to 348 factorial. So I'll just divide 348 with 5. So 5 6 are 30, 48 and 5 9s are 45, and we got 3 as a remainder. So I'll add 69 in this, plus I'll again divide this 69 with a 5. So 5 1s are 5, 1 9, 5 3s are 15. I got 3 as a remainder, plus 13, plus I'll again divide this 13 with a 5. So actually it's becoming a division problem if we know how to do and what to do. So 5 2s are 10, I'll subtract them, I'll get 3 as a remainder. So plus 2, I cannot divide it further because if I'll divide 2 with 5, I'll get 0 as the quotient. So this number of zeros at the end of 348 factorial will be 69 plus 13 plus 2. Now finally let us move to this 17 factorial. So again the same process, I'll divide this 17 with 5. So 5 3s are 15, I'll get 2 as a remainder. Now I cannot move further because if I'll divide 3 with 5, I'll get 0 as a quotient. So this thing will have just 3 zeros at the end of it. So now let us add all the values that we obtained here so as to get the total number of zeros at the end of this whole product. So 228, let me use the same color. So 228 plus 45 plus 9 plus 1 10 is equal to 55. So this is equal to 8 and 5 13, 5 7 and 8 and 2 283. This value here is equal to 69 plus 1 is 70 plus 13 plus 1 is 14. So this will give me 84 and plus 3. So 283 plus 84 plus of 3. Now let us add them together to get the total sum. So 6 and 4 10 0, 16 17 1 3, 370. Oh my god. So this factorial, this total product here will have 370 zeros at the end of it.